Good day. In this video, I'm going to showcase our final year project developed by the Cayenne Solutions team. This presentation will commence after project description, documentation, features, and problems encountered throughout the project lifespan. This project was developed to facilitate students who are or will be doing the course Theory of Computing as a requirement for their degree. The project entails a website desktop application that can be used by students as an educational tool for better understanding on the topic of finite automators. This topic is known to be a bit troublesome for some students, hence, the decision was made by the Cayenne Solutions team together with our project coordinator to help mitigate this issue students are facing. Firstly, the features of this project entails a regex converter that allows a user to input their irregular expression and observe the relevant DFA or NFA which is associated to the regex provided by the user. The project also showcases a trace-through feature that will allow users to attentively imitate the structure of a DFA or NFA in a step-by-step process with the use of visually appealing animations. Lastly, the project will also showcase a canvas feature that will allow users to draw their own version of a DFA or NFA, which will promote your better understanding on the topic. I'll now pass you over to Samantha.
An important step of the software development cycle is documentation, which helps with the monitoring of the overall progress of the project. Some diagrams that help with this are the use case diagrams, burn-down charts, sequence diagrams, mock-up diagrams, and system overview drafts. For now, we will just look at the use case diagram used to track the main features and the interactions between our users and the system, and the burn-down chart that is used to track the team's performance. Now on to Kyle.
The burn-down chart has proven to be beneficial for the project development stages based on the following deductions. The graph shows that while the completion of Sprint 1 was undergoing, the team had contributed precise efforts with minor struggle in comparison to the sprint completion in reference to the blue target line as depicted above. Each of us will now discuss our progress so far. Reasons for the Google Auth and API implementation. The implementation of Google Auth is used to avoid the common practice of using a database to save login credentials. Hence, with this implementation, maximizing time efficiency will be upholded. However, the problems faced while implementing Google Auth was the implementation of a RESTful API. Establishing the reference import modules needed for the GitHub project had proven to be unsuccessful. The callback URL reference to GitHub project was also unsuccessful, hence, the routes, both get and post, were not established due to invalid referencing of import modules. I'll now hand you over to Samantha.
One of the features we thought would be important to the project is the canvas feature that allows users to create their own DFA and NFA diagrams, while having the ability to convert and download it as an image. To implement the canvas, .script and D3 graphers were used to create the diagrams so that they would be easy to manipulate. Each diagram will start from a basic template of two states connected by an arrow. From there, users will be able to add new states, an accept state or regular state, and arrows, or delete them as necessary to create new graphs. As shown in the image on your right-hand side, originally an HTML canvas was used to draw each object on the screen. In the example, an arrow is drawn onto the canvas using X and Y coordinates, which didn't prove to be the most efficient method, as there would be a need to allocate storage to keep track of each object added to the canvas and how they interact with each other. A more efficient version shown on the left-hand side is using D3 graphers, a JavaScript module that allows the manipulation and rendering of a .script object, which seems to be more appropriate for the project's needs. Now on to Rayan.
So, as aforementioned, the whole premise of our project is to develop a converter that would convert regex into a visually appealing finite state automata that will also allow users to visualize how trace-throughs would look given a valid input string and how the DFA or NFA processes said input string. So, as a foundation, we decided to exploit existing technologies for parsers. Of course, it's impractical to try to go straight from regex into rendering it on an HTML page. So we made use of automata.js and regbrowsify.js. So as you can see from the screenshot on the left-hand side of the code, automata.js was used as the parser to convert the regex to an FSM object and then this FSM object was converted into its appropriate dot script. On the right-hand side, you will see the layout of the FSM object. It has the accept stage, transitions, the type of automata, the number of states, and the initial states. And below, digraph finite state machine is the dot script conversion of this FSM. So as Sam said, we'll be using D3 graphics to show a rendering of the graph. In this example converter, when we click this button, we see the finite state machine show up, and then that is given a previously defined dot script. And the transition button applies transitions to each of the elements. Now, to facilitate our trace through option, we would like to move these transitions instead of being applied to every node and text and arrow at once, for it to be done one at a time, so that users could better visualize how input strings can move along each arrow and then a respective node depending on the validity of the input string. Now, in order to have a better trace through, what we intend to do is edit the dot script file itself. So the dot script for every finite state automata, we will add a fill color attribute to it, and then we will alter the fill color attribute while the input string is being run through the states of the finite state machine. Therefore, when an input string is valid and it moves along an arrow, the arrow's fill color attribute will change to, for example, green. And the node value will also have its fill color change to green when that state is reached by the input string. So as an example on our site, we can see here that users can enter their regex into this input tag and convert it to show a NFA or DFA as respective. And it currently has a scroll overlay bar, and a feature that will additionally be implemented in the future would be the option to full screen the HTML elements of the diagram so that users could better visualize diagrams, especially when they get more larger and more complex. So thank you everyone. That concludes Cayenne Solutions' presentation of their regex converter to display finite state automata.